Start now. And just for the record, this will be put on the Pure Leader YouTube channel. So in the event that you have to leave early or you kind of missed something earlier, then you can go back and check and it should be uploaded by the end of today. If not, then tomorrow. So let's go over the first set of study questions that Dr. Saupe has given. The chapter 1 to 2 study question 1. So let's start off here. Let's see, draw. Perfect. So going off with the first question, seeing as it's asking, again, periodic table will be given during the exam, don't have to worry about that. And it's asking us to use significant figures and the rules of rounding for all our answers or for all our final answers here. So for the first question, it's saying that if the density of a brine solution, which is salt water, is 1.2271 grams per milliliter, how many milliliters are needed to obtain 7.66 grams of brine? So to start off with this question, let's write down what we know. So what information is this problem giving us right now?
Density and
It's
mass.
giving us volume and grams.
Yeah, all of you are correct. We're given a density and we're also given a mass. So yeah, perfect. So let's write that down. That way we know it's right there in our face so we remember. So we have a density of brine water, which is 1.2271 grams per milliliter. And we also have a mass, which is 7.66 grams of brine. So I'm just gonna put brine here. Let's see someone in the chat. Oh yeah, yeah. If you guys have any questions and don't feel like you're too shy or you feel like you want to put it through the chat, you're more than welcome to. Our peer leaders are present here, can help you guys with that. But if you want to say it out loud and so you don't forget it, you're more than welcome to. So as I set up my charger, because my laptop's about to die, sorry about that. What's the first, now that we have the information here from the problem, what's the first thing I can do? Because it's asking us for a volume, right? So we're missing a volume. So let's write that down underneath what we know. So we're given density and we're given mass for both brine. So what can I do to start going towards milliliters? What can I do to find my volume given the information I have? Do you guys have any ideas?
You can make a
Can't you
conversion
plug
factor.
it into the formula? Like density equals mass divided by volume.
So we can do that. And Noel, what were you saying as well? I was just saying that you could use the density as a conversion factor. Yeah, both ways are correct, right? Yeah, both ways are correct. So we can either use density as, the density formula for finding volume, as well as we can use the dimensional analysis as for a conversion factor. So let's do with that, because that's what we're going to be working with a lot here. So let's set up my dimensional analysis table. So what's the first number I need to place up here on my upper left? 1.227 grams. So if I put my 1.227 grams, remember this is grams per milliliter. So for every, this number of grams, I have 1 milliliter. So it's an invisible 1 right there, right? So if I have grams here, then I would have milliliters here. Yes. So if that's, is there a 1 after the 7? Oh yes, there is a 1 after this. Is there? Yes, there is a 1 after.
So we're recording to the grams too?
Yeah, so right now, since we know that this is a conversion factor of grams to milliliters, like there's a relationship between them or a ratio, and we're given a mass of that substance, brine, and the problem is asking us for milliliters. So if we know that we're given a mass and we have a density, which is a relationship between mass and volume, we can convert what the mass we're given to the volume we're looking for.
So to convert from gram to milliliters, it'll be 1 times 10 to the power of -3.
Not quite, because remember, grams and milliliters are two different units. They're two different units. We have a mass, which is weight, and volume, which is space. But this is the conversion between them, right? So here, let me rewrite how you told me to put those numbers in right there, because let's put them in this little box here. So before I put them here, let's start off with 7.66 grams. That way we're only working with one unit at the top here, so we don't have anything to deal with down here. Since we know that this is a conversion factor, we want to start moving it to our next little slot here in our dimensional analysis. In this case, we want to cancel out our grams. And remember, the way we cancel out grams is our units is by dividing them. So how can I place this value or this ratio here? Because again, since we have this many grams per 1 milliliter, we can say that for every 1.2271 grams, there's 1 milliliter. And you can, it doesn't matter which one you place at the top or bottom, because since they're equal to each other by this ratio, then no matter what you put on top or bottom will be correct. So if I have this format like this, what number will I put at the top and what number will I put at the bottom in order to divide and cancel out my grams?
At the bottom, you put grams.
And then the 1.2271 grams on the bottom.
Yeah, exactly. We will put our 1.2271 grams at the bottom. And if that's the case, and it's a ratio, the whatever's correlated to it will go to the top. So we would have 1 milliliter at the top. So now that's the case. Let's make sure that our units cancel out. So since everything's being multiplied by the top and then divided by the bottom, whatever's being divided, their units cancel out if they match. And since we're being multiplied, the milliliters will add on to that final number. Since our problem is asking for milliliters, and in our dimensional analysis we're left with milliliters, then all it's left to do is to solve for the number. So if I were to multiply by the cross and divide by the bottom, what would my final answer be?
A.
A, and what is A? 6.24.
6.24 milliliters.
Exactly, milliliters. So don't forget your units. That's very important. So,
can I jump in here?
Oh yeah, go ahead, Jonathan.
Another way that I did it is using this little density pyramid. So you have density is equal to mass over volume. So you have G over ml. In this case, we're working with G over ml. We note by that. So here in this case, all you just need to do if you're asking for the density, if you're asking for, the density, you have this one and just cover it up. That's another way to kind of put the spin of it if you have these other values, right? So actually in this case, if you're asking for this one, how many ml, you have density and you have your grams. So in this case, you would just cover the ml and then you're left with grams and density. And so you can just see how it's grams divided by density. Man, I can't talk today. Does that make sense to everybody?
Yeah, I really like that. Thanks, man.
Yeah, so remember,
so that means that you would, the density in the milliliters, you would multiply those, right?
Perfect, yeah.
Okay, cool. Thank you.
Yeah, so that's another way of thinking about it. Like there's multiple ways you can do it because it's math. So as long as you get the right answer without exceptions, for example, then that method could be correct.
Okay, so sorry. So that little pyramid would work in any, like if it was like asking for milliliters or if it was asking for density, you just plug it in where it goes and it'll work.
Yeah, so again, it has to deal with the concepts of math where, there's multiple ways of getting the answer. And as long as you know what you're doing and why you're doing it, then it should work either way.
Thank you.
All right,
I have a question. Are we using 3 significant figures because of the 7.66 being the fewest amount of sig figs?
Exactly.
Okay.
Yes.
Gotcha.
So remember to always keep sig figs, and the way you can tell is by the numbers that the problem gives you. So if it's something like a mass, so density wouldn't really count because if it's brine water, then density is always going to be like a given, right? So say you had to memorize a certain density, then you can say like, oh, okay, that density is given no matter the circumstance. But this mass could be anything, right? It could be 8 grams, it could be 29 grams if it wanted to give it that. So but in this case, it gives us 7.66. And since we multiplied and divide by this number during what we did, then that would have to be the lowest number of sig figs that we have to keep.
Gotcha. Thank you.
You're welcome.
And for that triangle method, it's not going to work for example, let's say you're trying to get like milliliters and then to liters, right? It's going to be a completely different type of, or it's going to involve extra work.
It depends. Well, it depends on what you're given, right? So if you're given here, in this case, it's grams to milliliters, then you would use grams to milliliters, right? But if they give you the density in grams over liters, of course, you're not going to use grams over liters here. Because it's really just based on what you're given. And again, if you wanted to convert, if you're given grams over milliliters, but then you want your answers in like liters, then you would have to convert.
Okay, thank you.
Are there any other questions before we can continue? No? Okay, perfect.
If you guys have any questions, feel free to put them in the chat or say them out loud. Interrupt me if you feel like I'm talking too fast. Feel free to interrupt me. It's perfectly normal. It's perfectly okay. I know I talk too fast sometimes. So going on to number 2. So number 1 is correct. It would be 6.24 milliliters. And on to number 2, where it tells us a mixture of white beach sand and table salt, so NaCl, which is sodium chloride, was found. By washing the mixture with water, the sodium chloride was dissolved and washed away, leaving away pure sand. Now, what example of separating is this?
Heterogeneous mixture.
Would it be heterogeneous mixture?
Yeah, it would be heterogeneous mixture because we would be separating 2 separate things. So it would show that we had like a heterogeneous mixture, right? We had salt and then sand, right? Which are 2 different things. They don't seem to really mix perfectly that well. So when we separate them, we end up with 2 pure substances, 2 pure things, right? So here, let me mark this as red just to make sure to keep it there. So easy peasy, right? So let's move on to number 3. When converting 101 Fahrenheit to Celsius, which of these is the correct calculation, or which is the correct way to convert it?
I believe C.
Wouldn't it be C?
D.
C. So why do you guys think it's
Is
C?
it working?
Oh, no, were you saying something?
Oh, nothing. I just testing to see my mic working.
So what do you guys think it's C to start off with? Let me put this like this. So yeah, this is
Because
weird.
of
Like
the 9/5?
you guys are on track with the 5 and the 9, but you're almost there. You're half right with the 9 and the 5. It's something different there.
What is because of the -32?
No, not quite. That the -32 part would be correct. So
Is it supposed to be A?
Is it A?
yeah, it's A. There is a reason why it is like
Yeah.
that specifically, but it's such a long calculation and process that you guys don't have to deal with it. But A would be the correct way. So remember, it's 5. It will be your Fahrenheit -32 times 5/9.
So we want to calculate for some Celsius to Fahrenheit would more or less be the opposite of Celsius to Fahrenheit.
Yes, it would most likely be the opposite. They're like a weird different. It would be a different transition.
So from like Celsius to Fahrenheit, it would be just addition N, just 9/5.
I believe so. I gotta double check on that because Celsius and Fahrenheit are weird. But most of the time, you won't really be working with the Fahrenheit conversion that much. This is just to get you an idea of like you guys are working with it and knowing what to do.
Go ahead and move on, and I'll post the equations up on the chat.
Oh yes, thank you. So moving on to number 4. So density is a blank given these options here: intensive, extensive, exclusive. There's intensive, intense, or excellent.
Intensive.
Intensive.
Intensive. Yeah.
Yes, exactly. It'd be an intensive property because it does not change the way it is, or it does not change the mass in itself. Well, it's hard to define certain things, but yes. So moving forward to number 5. Let's see. Oh, someone's in the chat. Okay, that's you, Jonathan. Sorry, I remember you're gonna put them. All right. So number 5, we have 3.13 miles is how many micrometers, and it gives us the conversion of miles to kilometers. So let me make some space here. Hold on. Here, let me space this out so we can have the room to work with it. And now, so what information is the problem giving us right now? Like, what's it asking and what does it give us?
It's asking for
micrometers.
And it's giving us miles.
So it's asking for
Going back to the Celsius to Fahrenheit, should we memorize both of them, like from Celsius to Fahrenheit and from Fahrenheit to Celsius?
Yes, for this chapter, in this case, for your exam, you should, because Dr. Saupe might give you like convert this Celsius to Fahrenheit or vice versa. So just for this chapter. Yeah, and Kelvin as well. Yes, don't forget about Kelvin. So you may begin a problem in Fahrenheit and ask you to convert to Celsius. I mean to Kelvin. So you'll first have to convert from Fahrenheit to Celsius, and then from Celsius to Kelvin. Does that answer your question?
Yes, thank you.
Perfect. So seeing with the information is given, I heard all your answers perfectly. So it's asking us to find our micrometers, but it gives us 3.113 miles. And it gives us a conversion factor here. It tells us that for every 1.000 miles, it's equal to, or there is 1.600 kilometers. So that's.
We should start by converting the miles to kilometers.
So let's do that. Let's convert our miles that were given to kilometers first of all. So what number do I put at the top and what number do I put at the bottom in order to cancel out miles and be left with kilometers?
You put miles in the bottom.
So let's put, yeah, so let's put the 1, or just to be more specific here, that it gives us the 1.000 miles. And since it's equal to each other, like a ratio, we have to put our kilometers at top. So our miles will cancel out and we're left with kilometers. Now, the problem's not asking for kilometers, it's asking for micrometers. So
following that, I'd say we convert the kilometers to meters.
Yeah, exactly. Because if you're trying to go from, like, say, a higher, I guess I'm gonna say a higher level unit to a lower one, it's best to convert to the base and then to your lower level, and vice versa, right? From your lower to your base and then to your upper level. So what is my ratio? Oh, sorry, go ahead.
It'd be like 1,000 meters over 1 kilometer.
Yeah, exactly. Because for every 1,000 meters, there's 1 kilometer. So you can look at this like that ratio fraction that I showed earlier. So for every, I'm just going to shorten this to 1 times 10 to the power 3 meters for every 1 kilometer. And you can exchange these because since they're equal to each other, it won't matter what goes on top or the bottom. What matters is how we put it in our dimensional analysis here.
Will he be expecting us to put it in scientific notation or just standard? What's it called?
It depends.
You have to put it in scientific notation.
It doesn't necessarily have to be in scientific notation. You'll be given multiple choice really during the exams. So if you see any scientific notations, your choices, then try and solve it for scientific notation. But most of the time, the numbers will be small enough that you can just write it out the whole thing. I just wrote this in scientific notation just to shorthand it and save time right now. So now that we have this conversion here, we can cancel out our kilometers, and now we're left with meters. So how can I convert my meters now towards micrometers?
You put
to the -6.
So to the -6, where do I put that, the top or the bottom? Yeah, the bottom. Yes, because for every 1 micrometer, you have 1 times 10 to the power -6 meters. So meters will cancel out. And now we're left with our final desired units. So once we have our final unit in our dimensional analysis table, we multiply across and divide by the bottom. And what does that give me for my final answer?
4.9808 times 10 to the 9.
Let's see. Let me double check that because like the key is kind of weird on me. Let's see, divide by 1. And can you repeat that again? Sorry.
4.9808 to the 10 to the -9 times 10 to the -9.
0 times.
I mean to the 9. My bad.
To the positive 9. Yeah, don't worry about it. Yeah, so that would be the correct answer. So 4.980, or you have like 4.981 as well. They're close enough, so that would be right. So yeah, so let me clean this up here to where this here. Oh, and what are your units here actually? Because this is almost incomplete.
Micrometer.
Exactly, micrometers. So your final answer would be 4.981 or 4.980 times 10 to the power 9 micrometers. Exactly, good job. So if you guys have any questions, feel free to ask them. Sorry about that. So for number 6, how many protons and electrons are in 7? Did I copy this right? Number 6. Oh, I see. So it's asking us how many protons and electrons are in lithium 7 or lithium 7 ion. So
there's 7 protons.
So going in order, so if you look at your answers here, we'll go from proton to electron to neutron. So, and this is an ion right here because it has the plus sign. It's denoted by a charge.
Wait, why is it lithium?
Oh, that's what the problem is. Right, I didn't copy the question right from the PDF, so it just said 7. But it's lithium 7.
Okay.
Would it be B?
So let's check B, right?
Yeah.
So we see that. So remember the number of protons. Why does it have? Why are you saying it has 3 protons?
Because the number of protons never
That's the
change.
atomic number.
Exactly right. So the bottom left number will be its atomic number, and that never changes no matter the isotope. So if it's 3, so we can count 3 right. And the 2 here, the 2 electrons. Why are we saying it only has 2 electrons?
Because it's
a positive charge 6 away.
It's losing an electron.
Exactly. Since normally ground state, so neutral lithium would have the same number of electrons as protons, but since it's positive by 1 charge, then that means it has it has 1 less electron. So yes, 2 electrons here. And the 4 here, since 4 neutrons, so remember your mass or the number of neutrons is, so let me write this here, number of neutrons.
The atomic mass minus the atomic number.
Exactly. So let me just change this. It would be your mass minus your atomic number. And that's how we get our number of neutrons actually right here. So B would be your correct answer exactly. So if there aren't any questions, we can move forward on to number 7 here, where hydrogen, deuterium, and tritium are isotopes of hydrogen. And what are the atomic numbers of all these isotopes?
D.
And why are you saying it's D?
It's D.
Because you just said the atomic number never changes.
Exactly, because if you were to change the atomic number, you would change the element itself. So perfectly like that. On to number 8, where hydrogen and lithium are in the same blank.
That's a weird question. Hydrogen and lithium are in the same group.
Group?
Oh, the alkaline.
Yeah, exactly. They're both in the same group, group 1. Perfectly like that.
And it's called the alkaline metals, right?
Yeah, they're called the alkaline metals. Even though hydrogen is not a metal, it's in group 1 because it has like a +1 charge when it becomes an ion. So it's more convenient to place it there. All right, so perfect, just like that. So if you guys are trying to copy this down, don't worry. This will be uploaded to the Peer Leader YouTube channel after the session, so you don't have to worry about that. You will be given, Anna, you'll be given a periodic table during the exam. So when you go on Respondus, there should be like a little tab in the test that should say periodic table. So
I can jump in here. Just remember that you are not allowed to use anything outside of your materials, outside of like pens, papers. They have to be empty, and your calculator. You cannot use your own periodic table, and it will be given to you by the exam. If you do not have a periodic table, then contact Dr. Saupe immediately, because that is a problem. However, you are not allowed to use any outside material whatsoever. And we are also going to be asking you, if you have like sheets of paper you need to use, please put it up to your camera during the webcam check and all that stuff. We will be looking at that. So go ahead, Alan.
All right, perfect. Thank you, Jonathan. So on to number 9. It's asking us, what is KCl and MgF2 called? So out of A, B, C, and D.
ACl would be potassium chloride.
C?
Wouldn't it be C?
Yeah. C.
Yeah, perfect. Yeah, exactly. It would be C because remember the reading rules. So with potassium chloride, obviously we have our non-metal being IDE at the end, and same thing with magnesium fluoride as well. So why, if it's C, why are we not picking B?
Because isn't fluorine like a diatomic element?
It is, but here we're with magnesium fluoride.
Is it because it's an ionic compound?
Because the metal and non-metal.
Prefixes for the anion?
Yeah.
So I heard. Oh, sorry. Go ahead.
If I remember quickly, when you're making the metal and the non-metal, you don't use the prefixes at the beginning.
Exactly, because since they're ionic, they have a set number of charges. So whenever you bond them and you say their name, so magnesium fluoride,
it's given that fluoride, there will always be two fluorides since magnesium is always a +2 ion. Yeah, perfectly, just like that. And let's see, go to draw. And on to number 10, we have iron 3 bromide has, and which of these does it have from A through D?
The iron, charge 3, bromide, and a charge 1.
So does it have 2 bromide atoms and 3 iron atoms? 3 iron atoms and 3 bromide atoms?
Oh, would it be C?
Would it be C?
So why is it C? Why does iron 3 bromide have 3 bromide ions and 1 iron atom?
Because Br has a -1 charge and iron 3 has a +3 charge because of the Roman numerals.
Yeah, so you need 3 bromide atoms to balance out with the 3 iron atoms. Iron
Yes,
ions.
exactly like that. Perfect. Just like that. Good job. So going on down here, where we have 3 or 3. I wonder if I miscopy that one as well.
It was probably the one from the top.
Oh yeah, it was my. Actually, no, it's just there. Okay, so ignore this little lithium thing there. So we'll move on to number 11 here. So to 4 significant digits, what is the formula mass of phosphoric acid? And here we're given it, which is H3PO4.
Is the formula mass similar to the molecular mass or no?
Exactly, yeah, because here we're dealing with a formula. So you can also call it the formula mass since we're dealing with the molecular mass of the formula.
Yeah, so they're interchangeable.
So as you guys are working that out, who can tell me how can we find the formula mass of a compound?
By adding all their atomic masses.
You would add up all their atomic masses.
Exactly, right?
Yep.
B or D.
So D. So let's double check to make sure it's D. So since you guys said we had to add up all molecular masses of each atom, let's do that. We see here that we have 3 hydrogens, 1 phosphorus, and 4 oxygens, right? So what are the molar masses for each atom?
So for hydrogen, it's going to be 3.024.
Or or it could be 3.03 if you decide to round up there. That's fine. And for
I got 98. Yeah, I got 98.
Yeah, all right. So the answer is 98.
Oh yeah. When we're solving this, do we round the atomic masses or do we just keep them relatively the same?
You would typically, well, it depends. So for example, let me clear this out real quick. So say if you're working with like oxygen, it's like 15.999. It's safe to round it up to 16. Or if you have something like hydrogen, which is 1.008, typically I like to work with 1.01 because it's a little bit more accurate. But you could also keep it as 1 whenever you're trying to convert or deal with calculations with just the mass of the atom itself. So do kind of be careful with that. It is, but in my opinion, I prefer to stay as accurate as possible to say the second decimal place. But like for the example of oxygen and even nitrogen, I'll just round it to the nearest whole number at that point. So are there any questions or concerns right now? No? Okay, perfect. So just a quick reminder for finding, the molar mass or the formula mass of a compound. It's the sum of all atoms in the molecule. Let's see here in the chat. All right.
Sorry, Alan.
No, it's okay. Don't worry. So let's see. So going on to number 12, let me make some space here. Oh, I don't know why it's not letting me. Sorry, guys. The Google Doc for some reason doesn't want to work with me. All right, well, we'll just work on the side here. So for number 12, how many grams do 1.222 times 10? That's to the power of 14. Let me fix that. So 10 to the power.
I was wondering what that.
Yeah, it's a little copy paste error from the PDF. My bad. So How many grams do 1.22 times 10 to the power of 14 atoms of carbon weigh?
So we're going from atoms to grams. Yeah.
So let me write this down here. So that way, actually, let me go lower. That way we have room.
Let's see. First, we had to divide it by Avogadro's number.
So let's do that. So we have atoms of carbon. So let's divide by Avogadro's number. And what is Avogadro's number?
6.022 times 10 to the power 23.
And to the 23 what? Because we need to cancel out our atoms of carbon here.
Atoms.
So it'd be Avogadro's number of atoms of carbon. And what is that equal to? Like what unit will be left over?
Mole.
Perfect. 1 mole of, since we're working with carbon, 1 mole of
I'm
carbon.
sorry.
No, it's okay. That's perfectly fine. You guys are getting it down. The reason I like to emphasize like putting the elements or the compounds is because when you get into module 4 with molar-mole conversions, if you guys have gone over that recently, then yeah, especially with module 5. But so moving forward, I'm left with moles of carbon, but it's asking us for a mass in grams. So how can I convert my moles of carbon into grams of carbon?
We take the molar mass.
Divide by the molar mass.
Divide by the molar mass
of carbon.
Well, you wouldn't divide by the molar mass.
You want to multiply.
To multiply.
Exactly, because if we were to divide by the molar mass, we would have the mole, I mean, not the mole of carbon, my bad. I'm thinking of way ahead. I would have, say, let me erase this. I would have 12.01 grams and then the 1 mole on top, but we need to cancel out our moles of carbon. So yes, we would multiply by it. So we would have 12.01, or you could just leave it as 12, however you decide, since they're close enough to be rounded, grams of carbon over 1 mole of carbon. So we would cancel out our moles of carbon, and now we're left with grams of carbon. So what will be my answer? So let me just kind of scroll up a bit so we can see the problem. What will be my answer for 12? What is my mass in carbon of carbon?
2.437 times 10 to the negative 9 grams of carbon.
Grams of carbon. So let me just double check that.
I said 2.437.
Oh, 437. There we go. Didn't hear the 4. Sorry about that. Yeah, perfect. So it'd be, so let me clean this up. So your final answer here would be like what Joseph said. It would be 2.437 times 10 to the power of negative 9 grams of carbon. So that there would be your final answer. Has anyone gotten a different answer, or is anyone still confused? Any questions?
So I don't know if it's my calculator, but I got that, but I didn't get the times 10 to the negative 9.
Oh, did it show like the full number though? Like with a bunch of
Yeah.
zeros? Yeah. So a lot of times if you have like a big enough calculator, it'll show you all the zeros.
Oh, okay, okay.
Yeah. So that's perfectly fine. If you put all the zeros, it's still the correct answer. But if it's like a big enough number like that, then it's good enough to try count the spaces and then put in scientific notation.
Sorry, could you explain how it goes in the calculator, please?
So what you would do is you would multiply all numbers on the top. So all numbers up here that would multiply. And then what I typically do at the very end, I would divide my final number with every number at the bottom. So everything would be, the top would be divided with the bottom. So in the end, if your calculator, so if your final answer in your calculator, sometimes it'll show up as like say 2.437 E and then a number. So what this E means is the same thing as times 10 to the power of, and then it would be whatever number follows it. But like what happened with, sorry, if I don't remember your name, where it showed you the full number. So it showed you this, so 1, 2, 3, 4, 5, 6, 7, 8, and then there's the 9th space, 2, 4, 3, 7. Sometimes it'll show you just a full number if your calculator can fit it. So whenever you get like a large number like this, I would always like to just look at my calculator and count the spaces. So so remember, to get to scientific notation, I need a number between 1 and 9.9, just like this number here, and then times 10 to the power of the number of spaces it moved. But remember, if I moved my original number, so if my decimal originally moved to the left, my exponent to the power of 10 is going to be positive, but if I moved it to the right originally, it's going to be negative. So in this case, since I moved, if I were to like, if this came out of my calculator, for example, and I want to put in technical notation and I count the spaces, so moving it 1, 2, 3, 4, 5, 6, 7, 8, 9, up until I get a number between 1 and 9.9. In this case, it's 2.437. Then my exponent here, since I moved it to the right 9 spaces, it's going to be times 10 to the power of negative 9. Does that make sense? Does that help answer your question?
Yes, it did. Thank you.
Yes, perfect. All right. So going on to the last problem here on this chapter 1 through 2 review test practice. Sorry, that was completely convoluted. It's asking us, it gives us C7H16, and it's asking us, what is this compound called?
Isn't it heptane?
Mm-hmm. And why heptane specifically?
Because
there's 7 carbons.
Mm-hmm. Yeah, exactly. There's 7 carbons, right? Now, in the event that, say, you get a problem, so let me clear all this bottom up, or say like you get a problem where it gives you, it asks you for like the name, but it only tells you the number of carbons, but it asks you for the formula. My bad, I keep convoluting. So let me repeat myself, sorry. Like it asks you for the name, for the formula for a certain number of carbons, but you know the number of carbons just by the name, but not the hydrogens. So a little shortcut I like to use, or a little hint. So here you have CH.
Isn't the number of carbons like two times the number of carbons plus 2?
Mm-hmm, right. So let's say the number of carbons is N. We try to write the formula. But
exactly.
But we want to find the number of hydrogens, right? Because there's a lot of hydrogens and we don't know for certain. So
probably hydrogen will be 2 and plus 2.
Yeah, exactly. So it'd be 2 times the number of carbons, in this case N, plus 2. So let's say, for example, I ask you to write the formula of the alkane with 6 carbons. What would my formula look like?
C6 and then
H14.
14
hydrogen.
Yeah. Exactly, it'd be C6H14, right? So it'd be just like this when you're working with your alkanes, right? In case you get a problem where it asks you to write the formula out of the number of carbons. Let's see here in the chat. Yes, perfect, exactly like that. So this is it for the first part. Are there any questions or any concerns regarding this so far? No. Okay. So we can move forward onto the chapter 3 portion. So so for Jonathan, Diego, Brooke, would you guys like to lead the next one? Do you guys have it, the file? The chapter 3?
Don't. Can you send it to me or maybe put it on Sling?
Yeah, let me, hold on, let me send it to you right now. So let me stop the recording. So
let me tell you about, because you guys are geniuses and already know this, but for the people out there who are watching the YouTube video, this may not have been clear or all that stuff, but when you're naming alkanes, that's a weird A. Alkanes. All right, that says alkanes for them. It's mama eats peanut butter, right? So remember your first 4 is kind of different than the rest. If you notice, it was heptane, hexane, octane, and all that stuff. But your first 4 is mama eats peanut butter, methane, ethane, propane, and then butane, right? And just add the anes. And then in terms of naming, like naming covalent compounds, also kind of remember that the first 4 of your prefixes, so say like this, CF3 or CF4, that one's also different. So remember that it's mono, di, tri, tetra. Right, so remember that mono is 1, di is 2, tri is 3, and tetra is 4. Yeah, and then after that it's penta, hexa, hepta, the same thing as alkanes.
So that's CF4LB carbon tetrafluoride.
Look at him go. Yeah. Good stuff. Good stuff. All right. That's about all I wanted to say.
I have the file, so I can go next. Let me share my screen. Okay. So let's make this full screen. Okay. So this is the exact same review. Nothing different. I made something. So for this is the same review that you can find on Dr. Saupe's site. So how many atoms are there in 1.35 grams of what compound is this? Can anyone tell me? What compound? What's the name of the compound? What's this last portion called? You guys can hear me, right?
Yeah, phosphate.
Phosphate.
Okay,
Isn't it phosphate?
Yes, this is phosphate.
Ammonium, right?
Yeah.
Yes, and then this is
Tetroxide?
ammonium. Yeah, so phosphate and then ammonium. And then what is NH3, just as a question?
Ammonia.
Yeah.
Ammonia. Yeah.
Ammonia.
Yeah. It really
Phosphate.
stinks. Yeah, it's a really stinky compound. That one doesn't smell that good. But yeah, ammonia. Okay, so ammonium phosphate. So for this first problem, I don't know what's happening with my screen. Okay, so for this first problem, what are we converting to?
We're going from grams to atoms.
Grams to atoms.
Yeah, grams to atoms. All right, and then let's expand it. So from what are the steps that we have to take to convert? So we start off with
grams to moles.
From grams to moles.
And then to atoms.
Yeah, and then to atoms. Okay, and then what were we given? I always recommend writing what you're given and then writing your unknowns. The reason why is because it kind of helps you get started. It makes a solid base for your problem for you to get started and start working it out. So what were we given?
Given grams?
Yeah, we're given our mass, right? A mass
grams.
of ammonium phosphate. So NH4 PO4. Oops, sorry, that's not a 4. Yeah, PO4. And then we were given 1.035 grams. And then what's our unknown? What are we trying to find?
Atoms.
Atoms.
Yeah, how many atoms we have, right? So that's what we're trying to do. To convert from grams to moles, what's the first thing I have to do?
You need the molar mass?
Yeah, we need our molar mass. All right, so let's calculate our molar mass. So we have NH4, 3PO4. This is a kind of hefty. If you're starting off with calculating molar mass, I recommend writing it all out as a list. So we have nitrogen, hydrogen, phosphorus, and then oxygen. And then, so what's my molar mass for each of these elements?
See, since it's in a trio, we would have 3 nitrogen.
Yes, so we do have to. So yeah, we have a 3 here. And what do we have to do with that 3?
Multiply by nitrogen.
Distribute it, like we multiply it.
Yeah, we have to distribute it, right? So our nitrogen, what are we multiplying our nitrogen by?
3.
3.
Our hydrogen?
We would have
12,
42
12.
nitrogen in total.
Maybe 12?
12, yes, it'd be 12. So 3 times 12. 3 times 4, yeah, sorry. And then our phosphorus, do we have to multiply by anything?
No.
No.
And then our oxygen?
4.
It's 4.
4, okay. So whether it be, okay. So for nitrogen, we have 14.00 times 3, hydrogen 1.008 times 3. Phosphorus is 30.97 and 16 times 4. Can someone tell me what the molar mass is?
149.096.
Oh shoot, I made a mistake. Where did I make my mistake?
Was it nitrogen?
So water would it be 31? Would the mass be 31 or would it be 30.97?
It would be,
so it's not what the molar
you
mass is.
You
The
have
molar
like
masses are
4
good.
hydrogens and then 4.032 times 3, right?
So I'm here. I wrote down the wrong number for my hydrogens. I wrote down 3 instead of 12. The molar masses are good, and trust me, you guys. Every periodic table is a little different. Sometimes you will see oxygen be 15.999. It varies between periodic table to periodic table, but yeah, I made a mistake with the number of hydrogens, so what had to multiply it by.
This would be 149.096.
Sorry. Okay, yeah, 149.07. Can I get someone to second that answer?
Oh,
I got 149.096.
yeah, that's what I got
But
too.
I rounded that up to 10 because of the sig figs. So I got 149.10.
For these, we don't really need to round our sig figs. This is what we call part of the process. So this is not a number that we would be given. Our answer, what would our answer be based off for sig figs?
Our
given number,
answer would be
which
based
is
on
given
four
number.
4 sig figs.
Yeah, so our given number has 4 sig figs. So
Yeah, but I ended up getting 149.096 too.
0.86.
Yeah, I got that answer also.
0.096.
I got 149.066.
It shouldn't affect it that much. It's very small. It should be okay as 0.7. Well, we can leave it at 0.7 because it's still 149. Okay, so we have our molar mass. So to set up our graph or our fence per se, so 1.035, how would I set up my units?
The moles on top and grams on the
Moles
bottom.
on top and grams on the bottom.
Then who gets the 1?
The moles.
Mm-hmm. And on the bottom, I put 149.07. Okay, and then what's the next process? If I'm converting now from moles to atoms, so what do I have to use?
So you put 1 mole.
Avogadro's number.
Yeah, 1 mole on the
Yeah,
bottom.
Avogadro's number, right? 6.022 times 10 to the 23rd atoms per mole. Okay, so where do I put my units?
You put Avogadro's number on the top.
Mm-hmm.
And then you put 1 mole on the bottom.
Yeah, exactly. That's correct. 0.022 times 10 to the 23rd atoms. And am I finished? Am I done?
Yes.
Yes, you are.
Well, you got to solve it, but
Yeah, I have to
the
solve
setup
it,
is
but-
right.
But
Yeah.
yeah, you're done.
I'm just testing
Trick
you guys to make
question?
sure. I tend to, for the ones in my workshop, I tend to do that a lot. Even if you guys are right, I tend to ask why. But yes, you're done because we went from grams to atoms and we wanted to end in atoms. So what is my answer?
4.180 times 10 to the 21.
Let me just make sure. Can you repeat that number again? Sorry.
4.180 times 10 to the 21.
181. I got a 1 and
Yeah, I got 181.
I got 181 as well.
Really?
Maybe it's a little off, but it's still around there. 21. Again, the molar masses may affect it depending on which number you used here. But yeah, that should be the correct answer. Atoms. 4.181 times 10 to 21. Do I have the correct number of sig figs?
Yes.
Yeah.
Yes. Yeah, you do.
Awesome. Okay. Any questions?
No, sir.
No, I don't think so.
No,
Sounds
Diego.
good. All right. So, what is the molar mass of potassium phosphate? So, for these, let's break it up into its ions. So, how do I know this is an ionic compound, by the way?
Because there's a metal and a non-metal.
Yeah, it's a metal and a non-metal. So, doesn't really tell us. I'm just making sure and reviewing with you guys. I'm gonna turn on my light. It's getting dark here. Okay, so potassium. What's the formula?
39.09.
And first of all, we have to write a formula down because
Yeah, K3.
That's K.
Okay. What charge do I have?
Negative. I mean, +1.
It was +1.
+1. There you go. And then phosphate.
PO4.
Yes, PO4. My charge?
Negative.
And it's -3.
-3. Okay, so my full formula.
Be K3 PO4.
Yes, correct. Awesome. All right, so K3PO4. All right, so starting off, let's do our list of the elements. Do I have to multiply my elements by any coefficients?
Yes.
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 Potassium by 3.
Potassium and the oxygen.
Okay, and my oxygen, how much do I do it by?
4.
4.
4, yes. Okay, so this is 39.10 times 3. This is 30.97. And then this is 16 times 4. I'll go ahead and let you calculate that, and then so give me a little time to calculate it.
Got 212.27.
Yeah, 212.
All right, 212.27, yes. So once you add all that, you get 212.27. My unit?
Grams per mole. Grams per mole.
Grams per mole. Don't forget your units. Those are very important, especially when you're doing processes. Awesome. Right. Any questions?
Bless you.
Thank you.
Bless you.
Is everyone good? Okay. So the molar mass carbon-14. What do you guys think the molar mass is?
14.
Yeah, you guys are right.
Yeah, it would be 14.
14 AMU. That is your molar mass. Is there anyone that needs clarification on why it's 14?
Yeah, can you kind of remind me?
Yeah.
Yeah, can you
So
kinda remind me?
carbon-14, what type of molecule is this?
Isotope, right?
Isotope.
Yeah, this is an
It's an
isotope. And what do isotopes have?
Oh, the same mass, remember?
Not the same mass. What are 3 subatomic particles?
Protons, neutrons, and electrons.
And what do isotopes have a lot of?
Neutrons.
Neutrons, right? So carbon-14, what does base carbon have? How many neutrons does base carbon have?
6.
6, right? So if we were doing base carbon, so our electrons, our protons, and our neutrons. So we have 6 electrons, 6 protons, and 6 neutrons. Where do we get our atomic mass from?
Neutrons and
Our protons and neutrons.
Yeah, or sum of protons and neutrons. So what does this number give us?
12.
12, right?
Mass 12. Yeah.
So carbon-14, our electrons, protons, and neutrons. What numbers remain the same here?
Electrons.
E protons.
Protons and electrons.
Yeah, our protons and electrons, right? So 6 and 6. And then how many neutrons would we have?
8.
8. And then when we add these up, what do we get?
14.
14. There you go. So it's a little bit of an easy question because you could just look at the name. Is everyone good or?
Yeah, it's fine.
Yeah, good.
All right. Sounds good. All right. So the combustion reaction produces 12.3341 grams of carbon dioxide. How many moles of oxygen is this? Okay. So.
I take the grams divided by the molar mass of carbon dioxide, and I take over sugar.
Okay.
And then
so,
we take that.
Yeah. So Noah kind of already named a portion of our process. So we're converting from grams to moles. But after this, what do we have to convert to?
Carbon moles.
Am I looking for carbon?
Oxygen.
The ratio of oxygen to carbon dioxide in moles.
Molar ratio.
Yes, we're using our molar ratio in this process. And what is my molar ratio?
2
It's
to
how
1.
much?
2 to 1.
How many? Oh,
2 moles of oxygen.
2 moles of oxygen to 1 mole of carbon
2
dioxide.
mole of oxygen to 1 mole of CO2. That's correct. And then if I want to convert from grams to moles, what do I need?
Molar mass.
Molar mass. as always. And what was I given?
The grams.
The grams of carbon
Yes,
dioxide.
I was given my grams, right? So my grams, oh, sorry, that's mass, sorry. It's supposed to be mass. So we have 12.3341 grams. And then, so what's my molar mass of CO2? I won't do the list this time.
4.04.
44.01.
Yeah.
44.01 grams per mole. Okay. So do I have everything that I need to convert?
No.
To start my process.
You're not finished yet.
Yeah.
Yeah,
but
what do
you're
I
not
need to
done.
do?
You need to divide your.
You need to divide by the molar mass.
You have to multiply by the 2 oxygens.
Okay, so yeah, I still need to do the whole process basically. How do I set up my problem or my conversions?
One
You
mole.
put your molar mass in the bottom.
Yeah, and then
Yeah.
one mass.
Yes.
This is 44.
Okay, and then the next step. Oh, first of all,
And
what
for
compound am I
everything.
working with here?
Carbon dioxide.
Carbon dioxide. I recommend always write down what molecule you're working with. The reason why is because you know what you have. And then what am I going to convert to?
2 moles of oxygen per 1 mole of carbon dioxide.
Yeah, 2 moles of oxygen per 1 mole of CO2. And am I done? With setting up, am I done setting up? Can I go ahead and start calculating?
Wait,
Yes.
the molar mass is 44.01.
Yeah, but isn't that?
Oh, sorry,
bottom
44.01.
Oh, yeah.
Sorry. Thank you. Got that. Okay, yes. Now can I set up?
Sure.
Yeah. We can go ahead up. I need to cancel these out.
I have a question that's relevant to one of the questions I'm having trouble with. If we want to go from grams of a compound to the grams of a single element.
So how can we go? Is that what your question is? Sorry.
Yeah, I believe that. Yeah, let's see if we want to go from. Let's see, we have 12.34. Let's see if we want to find the grams of oxygen.
Mm-hmm.
How would we do that?
So if you want, okay. So first of all, can someone tell me what you guys get here before we get to that question?
0 moles of oxygen.
Okay, yes. So
That's
0.5605 mole of oxygen. Yes, that is correct. Okay, so your question was how do we find out how many grams of oxygen we have, right? So like if we were asked to calculate how many grams of oxygen we have present in these many grams of carbon dioxide. So from there, how would we convert? What would be our next step?
Multiply by the molar mass.
Yeah, we would multiply by our molar mass this time. But molar mass of what?
Oxygen.
Yes, of oxygen. The problem I always get stumped on is whether to use diatomic oxygen or regular oxygen.
That's the only question I was gonna have too, piggybacking, but it's just off of the diatomic ones because the first problem that Dr. Saupe ever did with us, he had like N2, so it was 2 mole of N2, and then he still multiplied it at the end of the equation. So that's why I'm not sure what we're supposed to do with those.
Sorry. So it's because I'm also in office hours currently. Yeah. So what molar mass would I use? Of O2 or N2?
On what goes again? What's molar mass we use?
Would I use
1O.
I would just use 1O.
1O and then multiply by 2 at the end, right?
Yeah, I divided by the molar mass of 2, and I got it wrong.
Peer leaders, can I get your input?
I think that no matter if you put O2 or just O, I think that's just a way of saying like what you're talking about. It's still the same amount of oxygen. Like
Oh
carbon
yeah,
dioxide,
but either
carbon
like
dioxide is
double the molar mass of either like
I think you would still
it'll
use
be
a
the molar mass
single.
of 2 oxygen or the molar mass of 1 oxygen. That's kind of different here.
Oh, sorry. I think you would
I
just
would
use one
use
single
both.
thing, so 16. I think you
I
just
don't.
call it O2 because that's how I think it is.
Here we're trying to find out oxygen singular. We're not trying to find, it would state whether it's oxygen gas. Oxygen gas, what is oxygen gas? The formula.
O2.
O2.
Yeah, O2, this
It'd be
is
O2.
this is oxygen gas. But we're trying to find out just pure oxygen, just O. So it'd be single, so 16.
My advice is one, it's probably going to be multiple choice. So you can see on the thing where it's this many moles of O2, this many moles of O. Or two, if it doesn't state directly to use oxygen gas or molecular oxygen or all that stuff, stick with O. That's probably a safer bet. But then again, it's probably going to be multiple choice where it says moles of O2. So there's that.
Yeah. You guys can test your different answers. You guys can test it if it's 32 grams over 1 mole and see which one matches. You're at multiple choice. But most likely your question on your test will match or will specify which type of oxygen you're looking for. So when I use singular oxygen, what do I get? How many grams?
.968.
Yes. And then this is grams. Don't forget your units. But yeah. That sort of answer your question. I don't know who it was who asked that question.
Yeah, it was me.
Okay. Any
Like,
further
one more
questions?
time to make Jack get the problems right. Hope I get it right.
Well, it takes practice. That's my recommendation. All right. So the next question is, what is the mass in grams of 17 atoms of gold? AU. So you guys already have the formula here. So what do we do? How do I start the problem?
By converting grams to
Grams to
moles.
moles.
But no,
No,
What am I starting off with?
Do you start from atoms to moles?
Molecules
I
mean
would.
atoms to moles.
Yeah, atoms to moles.
And then
And
moles
from
to
moles to
grams.
what do I go?
Grams.
Yeah, grams. All right. And then what was I given?
Gold.
17 atoms of gold.
Yeah, gold. And okay. So to convert from atoms to moles, what do I need?
Divided by Avogadro's number.
Divided
Okay.
by Avogadro's number.
So I need Avogadro, so 0.022 times 10 to the 23rd atoms per mole. Then to convert from moles to grams.
Molar mass.
And what is that molar mass?
Molar mass.
196.9 grams per mole.
196.9 grams per mole. Okay. So we have our conversion factor, so we can start doing our vents. So atoms of AU. And then you guys said divide, so what goes on top?
1 mole.
1 mole.
1 mole. 1 mole of what?
Gold.
Of gold.
Yes. I specify what you're working with. 6.022 times 10 to the 23rd atoms. And then what's next?
And you multiply, right?
Yeah.
Multiply by what?
The mole mass.
Oh,
Yeah, molar mass. So 1 mole of AU is 196.9 and 0.9. And then what ends up in our answer?
I got 5.56 times 10 to the negative 21 grams of gold.
Yeah, grams. Sorry, atoms. Grams of AU. And then can I get someone to second that?
Yeah, I got
Yeah,
the
I got
same.
that same
Yeah, I
answer.
got the same.
So, hey, I got the
Oh,
same
no,
thing, sir,
5,
but
4, 5, 6.
yeah. But so what about with the sig figs here? So then are we doing 5.6 because it's 2 sig figs in the original one, just like you said earlier?
Yeah, so yes. So here we have 2 sig figs, right? So if I
Okay.
want to correct this, what would it be?
5.6.
5.7 times 10 to negative 21.
Well,
Oh, yeah,
5.7 is a
5.6.
little much.
Or 5.6.
Yes, 5.6.
My bad.
Yeah, 5.6 is a little much. 5.7 is a little much, but 5.6 is correct. Times 10 to the 1 grams of AU. There you go. Questions? Is everyone good to move on?
Yes.
Awesome. Okay. I will probably stop after this problem. Brooke, can you cover the rest of the problems with them?
Yep.
Okay. All right. So what is the mass of 4.0392 times 10 to the negative 4 moles of bromine atoms? So what am I converting from?
Converting from
moles
to
grams.
I'm starting at
Yeah, I'm starting from moles to grams, right? Atoms is there to kind of throw you off. But yeah, we're going from moles to grams. And then, so what do I need?
Molar mass.
Molar mass.
Our molar mass, right? So what is our molar mass in this case?
79.90 grams per mole.
Okay, so let's set up. We're given it's 4.0392 times 10 to the negative 4 moles BR. So 4.0392 10 to the negative 4. Okay. And so how do I set it up?
We would put the molar mass on the bottom,
The molar mass on the bottom.
and 1 mole on the top.
No.
No,
I
you
think
put
it'd have to
1
be on
mole
top because you need to
and then
get grams.
Yes, my moles go on the bottom because I need to find my grams. So 79.90 grams. Peer leaders, can you handle the chat? Okay, and then am I done?
Yeah.
Yeah.
Yeah, I am. I'm testing you guys. Don't worry.
I'm just trying to trick us, dude.
Yeah, I know. Yeah, you are done. We cancel out our moles, and then we have grams, right? So what ends up being our answer?
I got 3.227 times 10 to the minus 2.
3.227 times 10 to the minus 2. Okay, that is
Grams.
what I got. Yeah, grams. Of what?
Oh, Br. What is it, bromine?
Yes, bromine. And then can I get someone to second that answer?
Would it be 5 sig
I got
figs
this.
instead of 4?
So if I want to make
It
this
would be
5 sig
five.
figs, what do I have to add?
A 0?
Yeah, we can add it to 0. So 3.2270 times 10.
Well, it was actually 2273, so.
My bad, 3. I'm sorry.
Oh,
My calculator didn't go that far.
Okay, yeah, mine didn't either. Okay.
Right. I'm using my dad's calculator. It goes pretty
No
far.
worries. It's all good.
You got a graphing calculator over there?
Yeah, it's a TI-89.
Let's go. All right. Nice. Any questions?
Nope.
All right. All right. Brooke, are you good to take over for a little?
Okay, yes. Sorry.
Okay. All right, let me stop sharing.
How long is this meeting going to be? from 6:30?
Yeah, till 6:30.
Hmm.
If you have to leave, that's cool. I just posted in the chat the YouTube link. So after this is done, we're going to post the full recording on YouTube. It just might take a minute because if you ever had to do that, you have to like download the whole thing and then upload it. So it should be
Yeah, I
on
still
like
gotta
later
finish.
tonight or at least by
Yeah, I
tomorrow.
still gotta get some time to finish the Connect homework.
Yeah, but we just want to make sure that y'all have like enough time and you have this resource in case you ever like miss something and you need to go back. So let me share.
Yeah, I think I have enough time here. I'll have to go to my leave.
All right. So can y'all see my screen? Perfect.
Yes.
Yeah.
Thank you. Okay, so we're on this question: aluminum ions and sulfate ions combine to form an ionic compound. So let's figure out first what type of compound. They already tell you that it's ionic. So let's try to figure out its formula. So what's aluminum?
3 plus.
Huh?
3 plus.
You have Al, and what did you say? I can't really hear.
I'm sorry, 3 plus.
Plus 3?
Yes, excuse me, yeah.
Okay, yeah. And then we have sulfate. What's sulfate?
SO4. 2
SO4. And then, yeah, it's the -2. So what's our formula in total?
Al2
SO4 parentheses 3.
Good job. And remember, you got to put that parentheses. You got to put that parentheses there to know that it's just the SO4 that's being multiplied by 3. Okay. So let's figure out the molar mass. So just like molar mass, we got to figure out how many atoms we got. So how many atoms of aluminum do we got?
We have 2.
2.
Yep. Cool. And then how many sulfur atoms do we have?
3.
Awesome. And oxygen?
12.
12.
Absolutely beautiful. So molar mass of aluminum times 2, what is that?
$53.96.
Can you repeat that?
53.96.
Perfect. And then sulfur and oxygen, y'all can figure those out. Can you tell me?
$96.18.
Cool. And then oxygen.
192.
So we add these all up, and what do we get?
I got 342.14 grams per mole.
Cool. Can I get other people to back this up, confirm, deny?
I got 0.14 broke.
0.14? Sorry.
No worries.
Anyone else get this, or just him?
Yes,
I got that too.
Okay, yeah, we're looking good. Yep. So moving on. How many atoms of oxygen are there in 12 point this many grams of this compound? So we're gonna look at oxygen. So we have 12 grams. We work with that that are given. I'm gonna write down the whole thing. 12 followed by 4 zeros, grams of Al2SO4, 3. And what's our next step? How are we going to cancel out these grams of Al2SO4?
You should put it at the bottom.
Bottom, yeah. So we already found the molar mass, so that's awesome. We don't have to figure that out again. 3.2.14 grams. And I know I keep writing this, but I always find it easier to know what compound you're working with. And what are we going to go to?
1 mole.
1 mole, perfect. And then what do we got to put on the bottom of the next part?
12 moles of oxygen per 1 mole of aluminum sulfate.
Yes, very good. So we're in moles of aluminum sulfate. So to cancel that out, we're going to put moles of aluminum sulfate. I wish this was shorter, but we don't have that. And then how many moles are in 1 mole of aluminum sulfate? How many moles of oxygen?
12.
Oh, very good. We found that out over here. And I don't know, I'm just gonna erase this part. Okay. And then moving on, what else do we need? How are we gonna cancel out moles of oxygen?
Avogadro's number per mole.
Mm-hmm. And what is that glorious number?
6.022 times 10 to the 23rd atoms.
If by the end of this
oxygen.
class you don't have like a fear of PTSD of this number, you didn't do it correctly. And that is atoms, right? Atoms of O. So are we done now? Can we start our calculation? Or do we have something else to do?
No, that is good.
No, I think that's it.
That is awesome, yes. So you're gonna go through, you can see, you can cancel out your units. Looks like we did this correctly, so multiply the top and multiply everything by the top, multiply everything by the bottom, and what do you get?
I got 2.5 times 10 to the 23.
2.5, 10 to the 20. Anyone else get this?
Yeah, I got
Yeah, I got that.
2.53 times 10 to the 23.
Okay, sorry, I'm fixing.
Yeah, it's the same.
2.53, so. And then what's our units? What do we have?
Atoms of oxygen.
Atoms of oxygen.
Yeah, beautiful. All right, so let's continue on. Just gonna scroll down a little bit. What's the name of this compound? Hold on. So we know that the compound looks like this. What's the name of it?
Aluminum sulfate.
Yeah,
Aluminum
good.
sulfate.
Yeah, and they even gave you like a small hint. They said ionic compound. And you already know that aluminum is a metal. At least I hope you do. Aluminum is a metal, so yeah, you're gonna use just first element good, second element just, that's sulfate, yeah.
I have a quick question.
What's up?
For the answer for number 2, is it just 3 sig figs? Even though we have the 12.0000 grams that was given to us? So would it be 6 in that case, or?
Yeah, you're right. Normally, sometimes like when you're looking at a test, they'll put like just this. But
okay.
if you're
Gotcha.
considering sig figs, it definitely would be 3, and then
It was 2.53454 times 10 to the 23. Atoms.
if you see like your options and like if this was A and this was B, that give you a hint. You'd be like, oh, I have to go use sig figs. But if it was like this was A and then C was something like 3.4 times 10 to the 23,
Yeah.
you know that it's mainly looking for if you did the conversion correctly or not.
Gotcha.
No, but good question. Awesome. So let's continue on. What is the mass of 0.000430009 mole of this compound? So we start with what's given. So what's given to us?
The moles.
The moles?
Yep. And that's moles of what?
Aluminum sulfate.
Cool. So we need to get to, it's asking for mass. I'm going to assume it's in grams. If it doesn't give you a specific like measure, assume that it's going to go to grams or whatever your base unit is. So how do we get from moles to grams? What do we got to do?
1 mole at the bottom and then molar mass at the top.
Awesome. And we already found our molar mass all the way up here, which is 342.14. So what's that number?
.14715 grams. I mean, it goes on, and we could use the amount of sig figs, I guess, but.
What did you say?
0.14715.
Yeah, and that's grams of aluminum sulfate.
Mm-hmm.
Yeah. Again, if you saw like the answer choices were all different depending on the sig figs, then you would calculate it, but sometimes, because there's like a lot of sig figs in here. But yeah, good. Everyone understand this question, like all of its parts?
I have a question.
What's that?
So for number 3, it says, what is the name of this compound? How do we know the difference, like if it's aluminum 3 sulfate? Or like how do we know when it's going to use a Roman numeral or not?
So your Roman numerals are going to come in when you're working with transition metals. So if you like look at that periodic table, I'm not an artist, excuse me. Like this whole section right here, these are like your transition metals, and the reason we have those Roman numerals is because these can have multiple charges. So like carbon always has a charge of, oxygen always has a charge of like -2. Well, let's say like copper, it can have +2, it can have +3, it can have +4. And usually when you're working with that, they'll tell you, or you can figure it out. But aluminum is not a transition metal. I mean, it is, but it always has a charge of +3 because it's like right here. So aluminum is always going to be +3, and we already know that sulfate has a -2 charge. Does that make sense?
Yes, thank you.
Yeah, and it's an ionic compound because aluminum is a metal, but it'll tell you if you're going to need it or not.
Oh, okay, got it.
Cool. So I'm going to go on. Okay, why do you think the masses of the elements increase as you go down a period or left or right or down a group? Again, very terribly drawn, quickly drawn periodic table. So it's asking masses increase as you like go down a group or go down a period. Why do you think? Anyone have an idea? Anyone lost?
Does it have to do with the electronegativity of the elements?
Not exactly. So the masses. What do we know of masses? What are they made of? How do we calculate the mass of an element?
Protons and neutrons.
Those neutrons, yeah. So how do these change as we go down the periodic table?
More protons?
Yeah. So as we go down the periodic table, it's lined up in the number of protons, right? You have 1 up here, you have 2, and then you have 3, 4, and all the way down. So it goes like that, and then what do elements in their most stable form have? Do they have the same number of protons as neutrons? Do they have different? What do they like to have?
The same?
Yeah, they like to have the same. Sometimes they don't, and that's cool. But remember, as protons increase, so will naturally your neutrons. But that's just the idea, like protons, that's your atomic number. And as we go down, they're lined up in order. So like 1, 2, 3, 4, 5, 6, 7, 8, 9. And the more protons you have, most likely the more neutrons we're going to have too. Does that make sense?
Yeah.
Okay. Kind of a conceptual question, but you're going to probably see these on your test. Okay. So let's move on to these questions. So calculate the molar mass of what element, what compound is this? Can someone name it real quick?
Potassium iodide.
Yes, potassium iodide.
Perfect. Magnifique. So this is potassium. Excuse my spelling. But yeah, so we find this by adding up potassium plus iodine. What is that?
$165.99 grams per mole.
Did someone else get this? Just him?
Yes.
Yeah, that's right.
Yeah, good. So, quick question, why don't we have to multiply these by anything?
Because it's just asking, well, it's just 1.
Exactly. We have no subscripts here, and when there's no subscript, you just assume that it's 1. So we did technically multiply them by 1, but anything multiplied by 1 is just itself. Cool. So now we have, what's the name of this element in compound?
Potassium bromide.
Perfect. And we get this by adding up potassium plus bromide. And do we have to multiply them by anything?
No, because it's just one.
Good. So what's this answer?
118.99 grams per mole.
Anyone else get this?
Yeah, I got that as well.
Okay. Yeah, very good. So now we have this compound. And what do we call this?
Sodium hydroxide.
Sodium hydroxide.
Why wouldn't we call this sodium oxide hydride or something like that?
Because it's not an ionic compound. Oh wait, no, I'm sorry, I'm tripping.
It's okay, I just like making you guys think.
I don't know, I just know we have to recognize the OH.
Yeah, totally. That's what you see.
Yeah.
Whenever you see that OH, it's a hydroxide.
Mm-hmm.
Perfect. So we figured out this is sodium hydroxide, so it's sodium plus oxygen plus hydrogen. And like we said, we don't have to multiply by anything because we only have one of each. So what is that?
39.118.
Grams per mole. Did anyone else get this?
Yeah, I got that too.
Yep.
Woohoo! Awesome. So now going down, we got this compound. So what do we call this?
Silesium hydroxide.
Sodium hydroxide.
Yeah, cesium hydroxide. So we get this by adding cesium plus oxygen plus hydrogen. And again, we don't need to multiply them anything because we only have one of each. Look at that.
I got 149.900 or 0.918 grams per mole.
Point, what did you say? I couldn't hear you.
1.8.
1.8?
918. I'm sorry.
9.1. Okay.
Grams per mole.
Did anyone else get this?
Yeah, I got that.
Woohoo. All right. Moving on. So what do we call this?
Calcium
carbonate.
Carbonate.
Yeah, awesome. Y'all can see the carbonate in there. So it is calcium carbonate. And we get this by adding calcium plus carbon plus oxygen. Do we have to multiply these by anything?
Only the oxygen.
Only the oxygen by 3.
Only the oxygen by how much?
3.
3. Beautiful. Yeah. So it's the mass of calcium plus the mass of carbon plus 3 times the mass of oxygen. What do we get as an answer?
100.01. Oh wait, no, it's 100.09 actually.
All right. Anyone else get this?
Yes.
I got that.
Woo. All right. Moving on. We got, what's this one called?
Lithium carbonate.
The
Awesome.
lithium carbonate.
Yeah, same idea. Lithium carbonate. So we have lithium plus carbon plus oxygen. Do we have to multiply these by anything?
Yeah, lithium and
Yeah.
oxygen.
Lithium and oxygen.
Yeah, lithium by 2 and oxygen by 3. Because remember, this is, they go directly to the element in front of the number. So, when you do that calculation, what do you get?
73.89. I think so.
You think you're not confident?
I can second it.
You second it? Oh, wow, look at that. All right. So now we got a written number, a written compound. So let's figure out its formula. So what is this iron ion?
Fe plus 2.
Beautiful. We have that plus 2 because it's the Roman numerals. And then phosphite. What's phosphite?
PO3.
Oh, 3. What's its charge?
Minus 3. 3.
Woo! So our formula will be Fe, yeah, I wrote my F's like that. Fe3, CO3, 2. So we add up iron plus phosphorus plus oxygen. So how many irons do we have?
3.
3. Awesome. Phosphorus, how many?
3.
1. Oh, just give me 2.
2.
2, yeah. You're going to take whatever you have outside of the parentheses and distribute it. So we got 2 times how many phosphorus and 2 times oxygen. And then, so it's 2 times oxygen, the amount of oxygen we have.
6.
6.
Ooh, look at y'all smarty pants. What do you get when you get all this?
325.49.
Oop, that was my fault. Hold on. 325.49 grams per mole. Did anyone else get this?
Yeah.
Yes? Awesome.
Yep.
Cool. Does anyone have any questions on how to find molar mass?
I don't think so.
No?
No.
So you're actually smart. Y'all have been studying, and I'm proud. Okay. Ooh. Page? Or is that it? Oh my god. No, I think that's it. Okay. My word wasn't working. It said I was on page 2 of 3, and I was like, I thought there was another page. So if anyone has any questions.
Will the exam be really similar to this? Like, is this like a good gauge, or?
Yeah, it's gonna have similar questions to the one that we're practicing. Any other questions?
Would you say if we know basically what we're doing with this review, we're good for the test?
Yeah, like you just take stuff that you've been given and you study it. So like this review and then anything that your professors assign you as homework plus whatever you learned in workshop. But like this review is a good idea of probably how your test is gonna go.
Also, like a little note on how Dr. Saupe likes to make his exams. He likes to make you almost think outside the box, because right now it's pretty basic because it's like the very first things that you'll learn in like general chemistry. But moving forward, expect them to come up with questions where like he'll give you too much information where say you're trying to find a density of water with like a mass, but it gives you something like caffeine or it gives you like it's something that's not related to it. So keep your eye out for that. As well as things to think outside the box where like you have to convert through something, but he's actually asking for something else, if that makes sense. It's kind of hard to explain it until you guys get those practice problems in the future. But Dr. Saupe likes to make you guys think outside the box a lot of times, so just keep that in mind.
Yeah, there was a question like that in the workbook where it was like asking about the grams of like an atom and I think it was like water, and then they brought up like caffeine, and I was like, why are they talking about caffeine? So yeah.
Yeah, one of the challenge problems.
I had a problem like that too.
Yeah, so keep in mind, like read what the question is asking specifically, write down what you have, and then see the stuff that you can work with, because then you'll see that, oh, I have too much information. I don't need the caffeine to work with this since I already have, you know, XYZ for whatever I need to look for.
Gotcha.
So do you guys have any questions, any concerns regarding, you know, the previous modules or any content you guys may still be iffy on that we can help you with?
Yeah, I had a question about formula units.
Okay, go ahead. Here, let me.
Sorry, so I don't like some, you know, when it asks for formula units, I'm not sure what it's asking for like exactly, because I'm not like sure if it's atoms and molecules, like because like you know how sometimes like atoms or molecules when you're converting them they're the same, right?
Mhm. Yeah, so you think of formula units like the number of atoms within a formula. So let's say, for example, sugar, right? So it's C6H12O6. And I asked you for how many formula units of carbon are there, right? And with that, all you really need to do is look at the formula. So
With that, how many carbons are within sugar right now?
6.
Yeah, 6. So you can say there's like 6 formula units. That's a really bad way to spell formula. Formula, yeah. It's. I'll just do a little red squiggly line here. So it's not Google Docs, but that's misspelled, I guess. So 6 formula units of carbon, right? But this could also mean that you have, say, 6 moles of carbon within this 1 mole of sugar, because 1 molecule. You can also say it's 6 atoms of carbon within 1 molecule of it. So you can look at it. So remember your conversion here, where we kind of went over moles, where there's 6 moles of carbon here of atoms isn't the same as in being 1 mole. So a mole of this compound of C6H12O6. Same thing can be applied to atoms if you want to narrow it down even further. So here you have 6 atoms of carbon within this 1 molecule of sugar. So C6H12O6. So formula units, just gonna like simplify down without that little explanation, is just the number of atoms that it specifies within that formula. So if I would say hydrogen, right? How many formula units of hydrogen are within sugar right here?
12, right?
Yeah, there'd be 12 formula units or 12 moles of hydrogen for every 1 mole C of sugar, or it's 12 atoms of hydrogen for every 1 molecule of sugar. Formula, there we go. Formula spelled correctly there. So formula units of hydrogen. Normally, a lot of times you don't write it as 12 formula units. You'll sometimes be writing as 12 moles of said element per 1 mole of that, or 6 atoms. But just remember, when it talks about formula units, it's talking about the amount of an atom within a molecule. Does that help answer your question?
Yes, it does. Actually, there was a question in the workshop, the workshop workbook that asked for formula units, and I was like especially stuck on that one, and I was I'm looking for it right now, but I'm trying to find it.
Mm-hmm. So let's see, how much time do we have? Oh, perfect. So as you find that, are there any questions that anyone else may have, or any concerns regarding this?
No, I don't think so.
Oh, I have a question actually. It's the challenge problem in the workbook, but it's just, so when I was reading it, so ammonia is a chemical commonly found in a household. I guess that's just useless information. But how many grams of ammonia are there in 3.013 times 10 to 23 nitrogen atoms? Like, I just don't. That's what that throws me off. So how many grams of ammonia are there in nitrogen atoms? Like, how does that make any sense?
I think it's asking for the equivalent. Like, you take the atoms of your nitrogen atoms and you convert that to moles, and then you take out the molar mass of ammonia from that.
Okay, yeah. I mean, because if the question had said that, but like, I guess because it threw me off, because it's like it's asking for how many.
Yeah, it's a little bit tricky, but that's how I saw that.
Let's see. Diego, Brooke, wanna help me out on this, because even this has stumped me. Because keep in mind, not certain peer leaders like prepare these questions ahead of time the semester before.
Yeah, like so I understand. I'm pretty sure Hector's right, but the thing is the way it's worded though, it's not asking for that. The way it's worded is asking for how many ammonia is there. Now, if it said how many nitrogen atoms can make, or can how many nitrogen atoms would form, I don't know, a certain amount of ammonia, but I feel like that question is worded wrong.
I'm gonna go here on a whim and assume it's like the equivalent on what I'm sorry, I didn't catch your name there, on what Hector said, I believe.
Mm-hmm.
Yeah, Hector.
Yeah, I'm believing that Brooke, Diego, you have an idea?
Yeah.
Wait, sorry. So which problem are we doing?
It was the second challenge problem for module 3, where it's ammonia. Where how many grams of ammonia are there in 3.013 to 10 to the power 23 nitrogen atoms?
I want to say that's
on page 94.
Luckily, like this is like on your peer leader, like this is extra credit. Like your challenge problems are extra credits. You don't have to worry too much about that.
For that one, the way I understood it was like, how many grams of ammonia can you make with 3.013 times 10 to the 23 nitrogen atoms.
Yeah.
Yeah, that's
That's the way I
understand too.
interpreted it, but I just wanted to make sure.
Yeah, 'cause I was breaking my head with that too. But
Yeah, that one was a little worded differently. The process I would take is find out what the ratio of nitrogen to ammonia there is. So the ratio would be 1 to 1 because 1 ammonia makes one, or there's 1 nitrogen and 1 ammonium. And from there, I would simply just convert from atoms of nitrogen to atoms of atoms, and then you can convert that to moles of nitrogen, and then use the mole ratio, where you convert from nitrogen to ammonia, and then you can from there you can start from there. Yeah, I can see it's a little worded differently. It's a little weird to think about it, but yeah, that's the process.
Is the right answer 8.50 grams of ammonia?
Let me check.
Let's see.
Real quick.
Yes,
This is module 3, right?
Yeah, module 3, second
yeah.
challenge problem.
I don't think they uploaded the module keys
for the challenge. Even
they didn't upload the module key for module 3.
Oh.
Really? I thought I had it.
Yeah, I actually need to tell I need to tell them about that.
Okay, we'll check on that.
Okay, I'll make sure.
You guys can work it out with them. That way, you guys can just double check with them.
Yeah, so we can double check here. So like we let's assume like the best way to understand this is it's a process where we take our atoms, convert to moles of nitrogen, then moles of ammonia, and then to the grams of ammonia. So let's do that, right? So let's clear all this and start this off. So we started off with, let's see, where's that number? 3.013 times 10 to the power of 23 atoms of nitrogen. So how can I firstly convert this to moles of nitrogen?
1 mole of nitrogen per 6.022 times 10 to the 23rd atoms of nitrogen.
So 6.022 times 10 to the power 23 atoms of nitrogen. So our atoms of nitrogen cancel out. Then what comes next?
1 mole of ammonia to 1 mole of nitrogen.
Yeah, exactly. Since they're 1 to 1, because there's 1 mole of nitrogen for every 1 mole of ammonia. So our moles of ammonia cancel out. Now, what is the molar mass of the ammonia? Because that's what we need to convert to grams now.
17.03.
And where does that number go? At the top or the bottom?
On the top.
So 1.03 grams of ammonia over 1 mole of ammonia. So our moles of ammonia cancel out. So now we can get grams of ammonia. So just to multiply by the top and then divide by the bottom, or divide the top with the bottom, and then let's see what we get. So 0.13 power 23. Let's see, divided by. Why'd I get a syntax error? Oh, that's why. Let's say I did that, then that.
Yeah, I got 8.52.
Yeah, me too.
And that's what it says on the key. You're correct.
And so 8 points. Sorry, can you repeat that?
It's like 8.5206. I just put 8.52.
Yeah. So here's the full number. So we'll just leave it at the full number for now. Grams of ammonia. So 8.5206 or 8.52 is correct. So there we go. Yeah. So I gotta find out who's writing these challenge problems.
It was probably Jonathan, to be honest. I'll check later.
Yeah. All right. No, but this is from just prep from last semester, so probably. So, all right. So we managed to solve this for now. So, any other questions now that we managed to figure out this challenge problem? How's it worded?
Actually, I found the one that I was trying to find.
Oh, perfect.
Actually, yeah, it was on page 92 of the workbook, and it was 2C. No, yeah, it was 2C. My bad. Yeah,
2C. So
yeah,
if a sample of beryllium manganate, so Be, and then Mg. Wait, manganate's O3, right, Brooke Diego, or is that permanganate? Or permanganate is O4?
First of all, it's Mn.
Oh, Mn. Oh, okay, that's right. Yeah. That's manganese. I always get those two mixed up.
All the time.
Yeah, okay, there we go. So BeMn. But permanganate is O4, no?
It's say manganate, so I'm assuming it's just O3. Because here's the thing, we don't really work with manganates a lot of time, so that's why we're kind of I'm kind of asking that.
I thought permanganate was O4, yeah, and it's asking for manganate.
Yeah, so let's go with O3. So saying that we have a sample of that of 83.7 grams, and it's asking us for how many moles of oxygen atoms are present. So it's kind of being redundant there, right? Because it's asking
Oh
for.
wait, I'm so sorry. It wasn't that one. It was actually the next one. It was D. How many formula units? That's the one. I'm so sorry.
Okay, that's okay. So how many?
Yeah.
Okay, so same sample. How many formula units? Well, it's kind of the same thing. It's technically the same thing. How many formula units of beryllium manganese are present there?
Well, manganate is MnO4 though, right? I don't know why did you write MnO3?
Because permanganates are O4. Because beryllium just manganate by itself, if you try to look it up, kind of doesn't exist in a way.
Yeah, but where's permanganate anywhere in here?
It's not written there.
Oh.
Yeah, that's why I wrote O3. Wait, did I write O4 initially?
Yeah.
Oh, that been my bad. Sorry.
Oh, well, because that's what my peer leader said that we would use for manganate. So that's what I used for all of these.
Yeah, because permanganate is O4. Yeah, because we don't work. I don't know why who wrote this. We don't work with manganates, so and they're very confusing. I'm so sorry about that, guys.
Yeah, if you take a look at real quick at page 67, you have a list of polyatomic ions. Yeah. Oh, that's why manganate is special. Okay, manganate.
Yeah, see MnO4.
Oh, so it's there
I got
as.
O4 as well.
Oh my god.
The oxygens.
There we go. So O4. Yeah. Man, we really got to change our workbook. I'm so sorry about that, guys. So manganate O4. If it says it's there, it's there. Yeah. So let's work with what you're given. And it's asking us for formula units. Now, technically, you could say it's the exact same answer as C, because if you remember back in the example I was saying what a formula unit is, you can say it's so here. So if I were to look here, how many atoms of oxygen are within this one molecule of beryllium manganate, I guess, not permanganate?
4.
Yeah, 4. So there's 4 atoms, right? But what happens if I have 1 mole of, say, beryllium, not permanganate, manganate? I really hate it. Sorry, guys. Beryllium manganate. How many in 1 mole of beryllium manganate? How many moles of oxygen do I have in there?
Well, same ones, right? 4.
Yeah, 4, right?
Yeah.
4 moles of oxygen. And so if I were to say how many formula units are within this 1 unit of beryllium manganate, how many do I have of oxygen?
You still have 4.
Yeah, 4. Yeah. So in the end, say our or I misspelled formula. Let's just do this. Did I? Formula. I'm just going to do the squiggly line. I still think it's wrong. So 4 formula units of oxygen. So if that's the case, then our conversion in the end should be the same as C, right? Because if we had to convert from what was the original number, grams to moles, and then from moles of a compound to moles of an atom, then you can still say it's the same convert. So let me work this out here for you guys. So let's work this out just so you guys can see. So we have 83.7 grams of beryllium manganate, not permanganate for some reason. And how can I convert my grams to moles right now?
1 over 127.95.
But 1 what over 127.95? What specifically?
1 mole of beryllium manganate over 127.95 grams of beryllium manganate.
Oh, can you repeat that second number again? Sorry.
127.95.
There we go, 0.95. Yep. And then grams of beryllium manganate. So our grams of manganate would cancel out. And now that I have moles, and you guys kind of see the correlation of how they're kind of the same number. So how many moles? So if I'm trying to narrow it down to oxygen, how many moles of oxygen would I have compared within 1 mole of beryllium manganate?
4.
Yeah, 4. So if I want to cancel my moles of beryllium manganate, I'll put that at the bottom. So for every 1 mole of beryllium manganate, I'll have 4 moles of oxygen. So our moles of beryllium manganate will cancel out. And honestly, right here, you can just leave it at that because it's the same as formula units. You have the exact same amount of, oxygens as if they were moles. So I'll just write this real quick down here and say red, where you have for every 1 molecule of, say, beryllium manganate, you have 4 atoms of oxygen. And for every 1 mole of beryllium manganate, you have 4 moles of oxygen. And for every 1 unit, technically, we'll call it a unit of beryllium manganate, you'll have 4 units of oxygen. So you'll see that no matter what you do here, when you're converting, you're gonna end up with the same number. It's just with formula units, it's technically the same here. But I say it's much easier to work with moles here because you know what a mole is. And if you know what a mole is, you can translate that to, say, your atoms and your units like this. So with that, what final answer did you guys came up with here?
I got 2.62 moles.
Yeah, I got 2.62 moles of atoms of oxygen.
2.62 moles of, say, since in this case it's asking for units, I guess you can just say units or moles because they're both really the same. Units of oxygen. So that would be your final answer there. Let's see, are there any questions or any concerns so far regarding this problem or regarding what might be on your exam or any other concepts right now?
For that problem, it's asking for how many formula units of beryllium manganate, not oxygen, or.
I'm sorry.
Yeah,
oh my
I was
God.
gonna ask that too. I was like,
That's why I was confused. Yeah.
Oh my God,
not,
yes.
yeah.
Yeah, it's okay for you guys to interrupt me. Sorry, I went off on the tangent. I was still in the previous. Sorry. So 4 million. Yeah, so I guess that would be the answer. So in this case, you would just stop right here. Because remember back with a mole, 1 mole is being equal to 1 unit. Here, we can just stop calculating right here where we convert from grams into moles.
Oh.
I'm
Wait,
sorry,
but according to page 87, we still would need to multiply by Avogadro's number to get to formula.
Yeah, that's what I did.
Multiply by Avogadro's number.
Let's see. Oh yeah, that little let's see, Diego and Brooke. Can you help me out here on this? Let's see. 2 formula units.
Because I thought formula units was, synonymous with atoms.
Yeah, atoms and molecules.
Yeah, exactly.
I mean, like, depending on what it is, but since we're getting formula units of the whole compound, then it's
right.
Yes, exactly. There you go. So whoever is, I don't know, in the chat it shows me being like, yes, okay, you guys are correct. Yeah, my bad. So you can think of it as one formula. I'm just gonna put form U. So for 1 formula unit is equal to 1 molecule of it. So yes, okay, you guys are correct. My bad. Yeah, that was a mistake on my part. So for me, now that we convert, say, from moles, and we'll use Avogadro's number like you guys said, right? So 6.022 times 10 to the power 23. Just gonna put FU. No, oh no, let's not put that. Let's not put that.
That's what I used.
Let's not put that.
Yeah, that's what I used too.
let's form. We'll do Avogadro's number of forms for every 1 mole of beryllium manganate. We can cross that out. And now we're left with formulas. I'm so sorry for that confusion there. I'll try and cut that out of the recording. So from here, how many formula units do we get now?
I got 3.94 times 10 to the 23rd formula units of beryllium manganate.
Me too.
So repeat number, was it 3.94 times 10 to the power?
Yes.
Formula, I'm just gonna put forms just to shorthand this, of beryllium. So I can't get over with FU, sorry. Of beryllium manganate. Yeah, so this would be your final answer and not what I just went over just now. Any questions before I somehow confuse you guys even more? Any concerns? Anything relating to what you might be concerned on your exam? Let's see. Oh, all right, I'll take that silence as a no, so clear that out.
So if it was telling us how many formula units in 127.95, it would be 1.
Yeah, technically.
Okay.
All right. Yeah, that's really about it. Really, mostly your exam will just be covering modules 1 to 3. Basically, Dr. Saupe likes to make his exams like his study questions, but at the same time, he likes to throw you some curveballs, being like, "Oh, here's like all this information," when really you only need like 2 or 3 snippets of it. So keep that in mind. Or sometimes he'll want you to think outside the box, where he'll tell you a conversion and give you some random information, where eventually you could lead that information to that random conversion he gave you. So with that kind of out of the way, any concerns, any questions you guys may currently have?
I do. Can we go over problem number 10 from the workbook?
Let's see, from module 3?
Yes, please.
Okay, let's go over that with the time we have left. So let me put up the whiteboard again. All right, so number 10, where it says, let me bring this closer. Excuse me there. So on a planet in another solar system, there are 4 known isotopes of Z, which are the following abundances. So here are abundances of Z. So we have element Z, for example, and it's telling us the abundances and how abundant they are in terms of percentages. So for Z40, it is 84.32% abundant. And then for Z42, it is 5.077%. Let's see, and then for Z43, it is, if I'm reading this correctly, yep, 9.002%. And then for Z44, that's a ugly 4, there we go. It is 1.601% abundant. And it's asking you to determine the molar mass of element Z on this planet if the mass of, let's see. Okay, so if the mass of Z40, so let's make this here, so the mass of it is, let's see, is 40.00 AMU, which is the same as its molar mass. Well, not the molar mass in total of the whole thing, but it's the molar mass of this specific isotope here. And it gives us for some of the other ones, where for 42, it is 42.00 AMU, 43 is 43.00 AMU, and for 44, it is 44.00 AMU. So I do believe on page 89, it does tell you how you can convert from them to them. So it's asking you for like the total for the molar mass right here, right? So let's see if I can find this correctly, because you all often don't really work with this. Since here, my bad. Let's see, you gotta relook here. So here, what you would do to find like the average AMU or the actual thing is technically this is not that much important information, if that makes sense. So what you would do is focus on your percentages. And what you do with your percentages, you would move your decimal 2 times to the left. So consider your percentages, you would get a decimal and then multiply by 100. So we want to divide it by 100. So let's erase this here. Where once we convert these numbers as so moving them to the left 2 times, so we have 0.8432, 0.05077, 0.09002, and 0.01601. So if you guys catch something off or don't understand something, feel free to interrupt me. So just double checking to make sure.
Is there a reason why we move the decimals, or is it just to make them easier?
No, the reason we move them is because mathematically, when you're working with percentages, your percentage used to be a number that's a decimal, and you multiply by 100 to get that percentage out of 100.
Right. So it's just for the mathematical equations, right?
Yes, exactly. Like you'll be seeing this when you like go over module 4 if you have, in terms of percent composition. So now we have this number here. So what's left to do is we multiply this by the number
that's associated with that isotope, which is technically its mass. So in this case, we will multiply this by 40, multiply this by 42, 43, and so forth, right? So if we were to add all those up while keeping let's just keep the sig figs of the numbers that we converted here, our percentages, to be as accurate as possible. So let's just, I'm just gonna help you guys do this just to save time. Times, so 0.8432 times 40, that gives us 33.728. And then we have 0.05077 times 42. That gives us 2.13, I was gonna round this up, 234. Then we have 0.09002 times 43. That gives us 3.87086. I know I'm writing all the numbers, I just want to be as accurate as possible here. And then we have 0.01601 times 44, which gives 0.704, let's shorten that 4 there, so 44. And what you do here is at the very end, you would add up all these numbers. So if we were to add up all these numbers, let's just, let's just add them all up. Sorry, my mind's just scattering. So if we add up 33.728 plus 2.13234 plus 3.87086 plus 0.7044. And so if you remember, so let's round this up. Let's just round this up to the second decimal place just to save time and kind of ignore a lot of stuff, sorry. So if you were to add all these numbers up, our final answer for here, which would be the molar mass of just Z, would be 40.44, either AMU or grams per mole, technically. So does this kind of help make sense of what you do here? Or did I confuse you guys along the way or not explain enough?
No, that was perfect.
Yeah. Thank you, Noel. Anyone else? Anyone feel like they had trouble or they were confused? Let's see, I'll take that silence as a no. So keep in mind, like this is one of those problems that it did give you too much information. But this is like a perfect way of being it. So it's a perfect way of following like an instruction that I showed you here on page 89 of your workbook on how to do this specifically. So with the time, we went a little bit 5 minutes over. So with that, let me stop the recording real quick.